Hello everyone, my name is Ayush and today I'll be talking about three different concepts: median, the interquartile range, and then using those to draw box plot, and then using box plot to detect outliers in your data set. Okay, so without wasting much time, let us start with our first topic, median. So what is median? Median is nothing but a measure of, just a second, okay, yes, median is nothing but a measure of center location of list of numbers. Okay, so if you have a list of numbers and you arrange them in ascending or descending order, then the center number, the location, the number at the center location is what is known as the median. Okay, so that is, in simple term, it divides the arranged data set into two equal parts. By arrange means that after arranging it in ascending or descending order. This is the very important step, to either arrange it in ascending or descending order. Okay, now let us proceed further. Now say you have, first I'll explain you with the help of example, then I will give you a general formula. Okay, now say you have odd number of data points: 1, 7, 8, 9, 11, 12, 4. Okay, as you, and now you, somebody asks you calculate the median. Now what will you do is, you will arrange them in ascending or descending order, and I have arranged them in ascending order. You can do in descending also. This is 1, 7, 1, 4, 7, 8, 9, 11, 12. So around 8, if you see, you have 3 data points on the left and 3 data points on the right. That is, 8 divides your data set into 2 equal parts. That means your median is 8. Okay, so now what the general formula is, that if n number of data points are odd and they are arranged in ascending or descending order, then n plus 1 upon 2th number gives you median. Like in this example, n is 7 plus 1 upon 2 means 8 upon 2, fourth number will give you your median. So 1, 2, 3, 4, yeah, so 8 is your median. Now let us see for even number of data points. Now again, first step, now if you say that our data set is here even, number of data points are even, I mean, then you arrange it in ascending order or descending order. I arranged it in ascending order, and then you see that around 7, 8, on the left side of 7 you have 3 data points, and on the right side of 8 you have 3 data points. So means 7, 8 divides the data set into 2 equal parts. So what you will do, you will take their average, and that will be your median. So in case n is even, that is number of data points are even, like in this case 1, 2, 3, 4, 5, 6, 7, 8 is even, then you take average of n upon 2th and n plus 2 upon 2th number. Okay, so n is 8, so 8 by 2 means 4th number, and 8 plus 2 upon 2 5th number. Okay, so let's see, 1, 2, 3, 4, 4th is 7, 5th is 8, so I'll take their average and I'll get 7.5. So this was my median. Okay, now we have to look for quartile. What are first quartile, second quartile, third quartile? They are very important. Okay, so let us see. If you have a data set, okay, say this is your data set complete, and every point here represent one point, and these points are arranged sequentially, means either in ascending or descending order. Then quartile 1, that is first quartile, is that point, that is which from the starting point contains 25% of your data point. Okay, quartile 1 is the point which contain your 25% of your data point. That is called quarter 1. Quarter 1, you know, like it is said that like 12, like if you see like this, that we have 12 months. Okay, January, February, March, April, and not January, February. In a country, quarter is defined bit differently. Okay, so what we need to do is, we need to understand that in that respect only, so that you don't confuse. Say our quarter start with April, May, June, July, August, September, October, November, December, January, February, March. Okay, this is your 12 months, and your quarter one starts from April. So this April month, May and June will be your quarter one. July, August, September will be your, okay, November, December will be your quarter three. Okay, let me go again. October, November, December will be your quarter three, and January, February, March will be your quarter four. So see, if you understand by this, your total number of data points were 12. First three, that first 25% will represent quarter one. The first then what is first quartile? First quartile will be the point which is the end point for the first quarter of your data, means first 25% of your data. So this is your first quartile. Okay. Similarly, Q2 is also second quartile, and it is also known as median. We have already discussed that. And similarly, quartile, third quartile is that which before that it contains 75% of data point. Okay. So now let us see how to calculate everything. If you have a data point and we have to calculate median, quartile 1, first quartile 2, quartile 3, and then we'll proceed further to the box plot. Okay, so first we will do it for even number of data points. Okay, so say these are your data points, and now your first step as usual is to arrange them in ascending or descending order. Now you did it 2, 7, 8, 9, 11, 2, 7, then 8, 9, 11, 13, 23, 27, 31, 32. Now you arrange them. Now first we'll calculate median. How will we calculate median? Again, the point which divides the data set into two equal parts. Now since 4, 4, 8 to 10, there are 10 data points. N is even, so simple n upon 2 and n plus 2 upon 2th number you have to find. So means 10 upon 2, 5th and 6th. Okay, this is 5, and 10 plus 2 upon 2 is 6th. So 5th is 1, 2, 3, 4, 5, 11, and 6th is 13. Okay. Now what you will take? You will take their average. That will come out 12. That is 11 plus 13 upon 2, and that will give you your median. So median is 12. Now how to calculate first quartile? So to calculate first quartile, what you will do? You will consider your data set from first point to the 11 one. Okay, you will include 11 with the point which you used in calculating median. So remember, this happens in case of even number of data set. Okay, for odd number we will see later. So we will include 11 also, and we will find the median of this data set. So here 1, 2, 3, 4, 5 odd number of data points. So you will have 1 means 5 plus 1 upon 2th means third. So this will be 8. So 8 will be your first quartile. Similarly, for third quartile, you will choose this data set 23, 27, 13. This 13 you will include 13 also. 13, 23, 27, 31, 32, and you will find the median of this set of number. Median is 27. So third quartile will be 27. Okay. This is how we calculate when we have even number of data point. Now let us start with odd number of data point. Okay, so again, see, in this example I have arranged them in ascending order, and this is a set of data point for which you need to calculate median, which is also known as second quartile. You need to calculate first quartile and then third quartile. Okay, so median is simple, odd number of data point, or 9 plus 1 upon 2 means fifth data point. Okay, so 1, 2, 3, 4, 5th, 11. So 11 is your median. Now when you will calculate quarter one, you will take only these four set of number 2, 7, 8, 9. So here you know that you will take the average of you will find the median of this, and how will you find? By taking the average of 7, 8. Okay, so this will give you 7.5. This will be your quartile 1. And for third quartile, you will find the median of this set of number, and this is the set of number. This will come 25. Okay, this is your third quartile. So this is how you calculate median, quartile 1, quartile 3. Okay, now let us see interquartile range. Now interquartile range is used to measure how spread your data set is. Okay, how spread your data set is, and that is calculated by q3 minus q1. So this is your formula, interquartile range. This is what? Interquartile range, q3 minus q1. This is how you calculate the spread of your data set. Okay, now for detecting outlier, outlier means something which you consider that is too far away from the majority of your data point. Okay, how do we do that? So for that you have to define a limit, and this limit is decided not based of any like important concept. It is decided or like by experience and by using normal distribution. And the formula which is said is that the maximum range allowed will be quartile 1 plus 1.5 into interquartile, with quartile 1 minus maximum is no. So quartile 3 plus 1.5 into interquartile range, and the minimum limit allowed is quarter 1 minus 1.5 into interquartile range. Okay, so what will happen is, you got, first you calculated quarter 1, quarter 2, that is median, you calculate quarter 3. Okay, then you calculate interquartile range, how spread your data set is, then you calculated your minimum, that is quarter 1 minus 1.5 into interquartile range, and then you calculated your maximum, quartile 3 plus 1.5 into interquartile range. Okay, now any data points which are less than minimum or which are greater than maximum will be considered outliers. Okay, outliers means these are some data points in your data set which are not clustered around, but they are far away from the majority of your data points. So they require special attention. So these outliers require special attention when doing machine learning or data analysis, anything of that sort. Okay, so this is why we need to detect outliers. Now let us see how will you draw box plot and what all more information we can derive from this box plot. Okay, see, so first what you will do, you will make this, say this is your median. Okay, this is your quarter 1, this is quartile 1, this is quartile 3rd, this will be your quartile 3 plus 1.5 into interquartile range, this point, and this point will be quarter 1 minus 1.5 into interquartile range. So, and you will draw like this. Okay, so these are the 5 points, 1 2 3 4 5, and then you will make such a plot. Okay, now one thing is, say you have a box plot, and any when you plot it at any point which will be lying here or here, these will be your outliers. Okay, so you just draw a box plot. A readily available command is there in Python, and in R also you can just write it and see what are your outliers. And I will suggest you calculate also once in using by writing code in Python or R, or you can use Excel also. Okay, now say what all other information you can derive. This is often asked question in interview. Now the one point is, you can also find out whether your data set point is skewed or not. Okay, skewed means whether it is like this. Okay, so you see that this is skewed here. Okay, now if you have to check it, how will you find it whether your data set point is skewed or not? You will do that simply by seeing your box plot, and if this distance and this distance, say this distance is x1 and this distance is, if x1 is much less greater than x2, it means your data set is skewed toward maximum. Okay, and if x2 is much greater than x1, means your data set is more skewed toward x1. So by looking at the distance, you'll be able to find out how skewed your plot is. This will give you a rough understanding. The best way to find whether your data set is skewed or not is by drawing histogram. Okay, histogram. We will see that in other lectures, how to draw it and how to interpret it. But histograms will tell you how skewed your data is. But as I told you this because sometimes it is asked in interview that whether you can do it or not. Yes, we can do. We can see how skewed our data is through our box plot. But the real way of doing it by using histogram. Okay. So this was all from my side. Thank you for listening to it. And in case you want me to cover any other concepts on any other lecture or give me any kind of feedback, please write it in a comment or you can mail me also. My mail ID is there on the channel. Thank you very much. Keep